All right. In this class, we just want to check how and what can we do in the application of our parametric equations. This is one of your aspects that you need to understand on your derivatives. That is the application of the parametric equations. All right. What are these parametric equations that we're talking about? What is it that we're talking about? All right. Let us take a closer look of having maybe two functions. Let us say we've got two functions. We are given x as a function of theta, all right, or of t, whatever function that you can think of. Let's say it's a function of theta. And also we have got y as a function again of theta, which is g theta, and f theta for x. These two functions that we are having, they're in terms of theta. All right, it's x in terms of theta, y in terms of theta. Maybe it can be x in terms of t. Think of any variable that you can. It can be in terms of t. X is equal to 2t, y is equal to 3, t to the exponent of 3. There are two equations that we have for x and y. Those are parametric equations. They are given in terms of the same variable, x and y. So how do we differentiate these? Because if we take a closer look, x, when given in terms of theta, definitely I'm going to have the derivative of x with respect to theta from here. That is what I can get from this. All right. From y here, what I can get is the derivative of y again with respect to theta. That is what I can get. But our derivative is not going to be asked this or to be asked this. We are going to be asked to find the derivative of y with respect to x. That is what we are supposed to know, or that is what you're supposed to have. So therefore, what is going to be the derivative of y with respect to x? Not y with respect to theta, not to x, no, but y with respect to x. Even though our answer is going to be in terms of theta, because this is in terms of theta and also this is in terms of theta. But we have to connect this to give us dy dx. How can we get dy dx from dy d theta and dx d theta? We can get this by dividing. That is the derivative of y with respect to theta over the derivative of x with respect to theta. That is how we can obtain this. I want us to get back to our mathematical calculations. The derivative of y with respect to theta, if you're dividing, what do? You multiply. And when you multiply, what do? You invert the second fraction. So this will be d theta dx like this. We invert, we interchange the second fraction. So if you see this and this will cancel, we remain with dy dx, which is the one that we want here, dy dx. All right. So instead of me writing it this way of a division, I can even write it as a product of what? D theta, dy d theta to d theta dx. The moment I multiply, I interchange. So it will be d theta dx. So it is just one and the same formula. So it depends with the how do you want to apply your formula as, but it's one and the same thing that you have. Here it's easier because it's just there is no need for you to interchange anything. As you can see, this is d theta dx, not dx d theta. Here you've got dx d theta. So what I'm simply saying is that if this is in terms of t, it's gonna be x in terms of t, which is dx dt. Also dy dt. So we have to write it in terms of what? In terms of t. In terms of theta, we use theta. That is it. That is what we have. All right. So this is the first one. And also they can ask you for the second derivative for y with respect to x. So this is given as the derivative with respect to, let's say we are talking about in terms of theta. So it's going to be d theta of the derivative that you calculated before, which is dy dx. All right. So we want to remove this d theta. So what do? We multiply by d theta over dx. So you're going to multiply by d theta over dx so that we get dx squared, not d theta dy, but d theta dx, so that dx and dx here will give us what? Dx squared. As you can see, this cancels here. We get d dy dx, which is dx squared. All right. So that is how it's supposed to be like. All right. So that's your formula. So I'm going to explain what this formula means. This formula, you have it in your formula sheet. So you just have to understand what it means and how to apply your formula. This is for the second derivative that you might be given. So with this information, I just want us to take 1 or 2 questions to consider. Let us see how they can ask these questions. Let's say we are given a condition. All right. Let's say we have got 2 equations that we are given. X, which is equal to e to the exponent of 2t, and y, which is equal to e to the exponent of minus t. These are 2 equations in terms of t. Those are parametric equations. And you are being asked to determine or to calculate the derivative of y with respect to x. What are you going to do on that scenario to determine or to calculate the derivative of y with respect to x? All right. So like I said here, in order for you to have the derivative of y with respect to x, you're going to need this formula. All right. If this is in terms of theta, if this is in terms of theta, but this is in terms of t. So meaning to say from this calculation, it says that the derivative of y with respect to x is going to be the derivative of y with respect to t. So you're going to have the derivative of y with respect to t. We divide to the derivative of x with respect to t. So that's the derivative of x with respect to t, just like that. Here it was theta, so that's why we're using d theta. Or we can write it like this as a product. It's up to you, all right? So having this formula, we can be able to calculate our derivative in this case, all right? From our x, remember, here we've got a condition, or we have our x being equal to e to the exponent of 2t. So what is the derivative of x with respect to t? We drop the exponent, remember the e, we find in actual sense, we just write e as it is, e to the exponent of 2t times the derivative of f of t, this function of t, which is going to be 2. So that's 2e to the exponent of 2t. The same thing for y is equal to minus e to the minus t. It's going to be the derivative of y with respect to t. We do the same thing, e to the exponent of minus t remains as it is times the derivative there. We need the derivative with respect to t, that will be a -1. So this will be minus e to the exponent of minus t. So it is just a situation of combining your terms. Yet the derivative of y with respect to x is equal to dy dt. That is the derivative of y with respect to t. We got it here as -e to the exponent of minus t over the derivative of x with respect to t as it is. This is the derivative of x with respect to t, which is 2e to the exponent of 2t. We are just taking this part as it is. So we can simplify further from this, all right? Taking a closer look, you can see that this is just same as -1 over 2. So that's -1 over 2. We are dividing the bases that are the same. This is e, this is e. We are back to our exponents. The bases are the same. What do? You subtract the exponents. So it will be e to the exponent of minus t minus 2t. So minus t minus 2t, that's what? Minus 3t. So it's e to the exponent of minus 3t, like that. So that is how the questions might be given as. All right. So you just have to try, by all means, to just play around with the information, how it is given. Is it given in terms of t? Is it given in terms of theta? Whatever that you're given, you have to formulate the equation, whether it's for the first or for the second derivative, whatever that you are given there. Just have to play around with the information. All right, no problem. So just let me just put this properly. This is theta dx. All right, sorry for that. Okay, so no problem. Let us just check one or two questions. These are the typical questions, how you are given these questions. On these questions, if the parametric equations are of functions are given as, so these are the two functions, and you're asked to find the second derivative of y with respect to x. All right, so let us just check, take our information. Just gonna write, okay, the formula we already have. I wrote the formula before. Let me just take this aside. Remember here we've got our x. All right, let's do this. Our y is equal to sine 4t. Sine 4t, and our x is 2 pi cos 4t, like this, and this we need the second derivative of y with respect to x. All right, so from the formula we said, in order for us to have the second derivative of y with respect to x, we are going to use this formula. That is the derivative with respect to the variable that you're given. In this case, is t, not theta. So that's d dt of the derivative that happened between y and x, which is the derivative of y with respect to x, which we got before. And we know that this is going to be in terms of what? In terms of t, because it must be differentiated in terms of what? In terms of t. All right, if it is a theta, it's like that. This one, if this is theta, this one is going to be in terms of what? In terms of theta. Depends with what you're given. Times, we need to eliminate this dt. So what do? We multiply by dt dx, so that this also gives us the x squared. So that's it. So let's fill in. Let's see what we have. From this x, y here, we're going to find the derivative of y with respect to t. Remember, sine, it changes to a cos, but this here multiplies. That is, we're going to have the first derivative. Remember, it's the first derivative of f of t, and it changes to cos f of t, right? So the first derivative, that is the derivative of 4t, which is 4. So it's going to be 4. Then it changes to cos 4t. All right, then the derivative of x with respect to t, in this case, cos, remember, changes to negative sign, but this number multiplies here, so it's 2 pi times 4, but being a negative, so it will be negative 8 pi. Multiply this because it's going to be a sign, all right, a negative sign. So that's negative 8 pi sine 40, okay? That's what we are having in this case. So with the information or with these calculations that we have, we can simply substitute the information that we have into the formula. And I want you to understand this formula. It states that the second derivative of y with respect to x is going to be the derivative with respect to t. This is what it means. You are going to differentiate with respect to t what you obtained previously from dy dx. All right, we have dy dx. All right, we haven't finished here, so we need dy dx. We find dy dt, dx dt. So remember that dy dx is given by the formula dy dt over dx dt. Okay, so this one is just a substitution. Dy dt, when we differentiated y with respect to t, we got 4 cos 4t. All right, over the derivative of x with respect to t, we got negative 8 pi sine 4t, like this. All right, so this is what we have, and we can simplify. As we can see, the numbers can be divided. 4 here, that's a 1. Here, that's a 2. So it's going to be negative 1 over 2 pi. You can just write it as negative 1 over 2 pi. Then remember that cos over a sine, if these two are the same, 40, 40, the cos over a sine, it gives us what? A cot. All right. If it is sine over cos, it's a tan, but cos over sine is a cot. So this will give us cot 40. So this is the derivative of y with respect to x. We got this part. So we're going to take this into consideration. Negative 1 over 2 pi times cot 40, like this. This is what we got, cot, not cos, but cot. So this is cot for t like this, right? We are replacing here dy dx. This is our dy dx, right? Dy dx from what we got. So it means you are supposed to differentiate with respect to t, whatever that you have here. That is what I was saying in terms of t. It's going to be in terms of t. Times, this one is not a, it's a product. We are going to multiply what we got previously. Because this t dx is just the inverse. Remember, we had dx dt. What happened? To have dt, it's just an inverse. 1 over what you have. This is your dx here. We calculated here. Our dy dx, all right? We calculated here where we had x. I want us where we see where we here. Dx dt, this is just same as over 1 like this. So if I want dt dx, I'm just interchanging 1 over also. So meaning to say, where I want here, the t dx is the inverse of dx dt. The inverse dt, we just interchanged this. We also have to interchange 1 over, so it's going to be 1 over negative 8 pi sine 4t. So this is our dx dt. Okay, just interchange. So we can simplify further in this case. Okay, this is going to be, like I said, this we are differentiating whatever that you have here with respect to t. So what is the derivative in this case of a cot? All right, how do you differentiate a cot? Remember, cot, it's a cos, it changes to cosec, negative cosec squared. And this number multiplies whatever that you have. So it's going to be negative 4 cosec squared 4t. The derivative of 4, which is this, but it is a negative for cot, all right? Times what we got previously, which is 1 over negative 8 pi sine 4t. Remember, we got this from what? dt dx. So this is what we have, and it's just a matter of what? A simplification to happen. So what are we going to have in this case? If we simplify further, that is going to give us negative, which is a positive 2 into 4 here. That's a 2. So it's going to be 2 over pi. 2 here, we got a 2 times 1 over pi. So it's 2 over pi. Cosec squared 4t times 1 over negative 8 sine 4t. Okay. So that is what we're supposed to actually have. But we can simplify further. We've got other things to be simplified in this case, all right? Like what? We can multiply, combine everything at once, because this is just like over 1. So you can multiply the numerators together. That will be 2. Cosec, or let us just leave it like that. Like, let us just multiply these together here. 2 here, that's a 1. 2 here, that will be a negative 4. So you're going to get 1 over pi times 1 over negative 4 pi, like this, 1 over pi times 1 over negative 4 pi. This will be negative 1 over 4 pi squared, right? So this will give us 4 pi squared. Pi times pi, that will be pi squared. Then we have got a cosec. This is a cosec squared 4t. Okay, times 1 over a sine. Remember, 1 over a sine. Sine changes to cosec. 1 over a sine is cosec. So this will give us cosec 40. So that's it. We've got a cosec and a cosec. We can combine this from our trigonometry. That means we're going to have negative 1 over 4 pi squared. Cosec squared 40 times cosec. We are multiplying the base that are the same. Just add the exponents. So this will be cosec to the exponent of 340. All right. That's it. Because you're considering a cosec and a cosec. So you're just going to add the exponents here. 2 plus 1, which is what? Which is a 3. Okay. So that is the basic information that you need. This is the basic information that you need. Just have to calculate calculate first the derivative of y with respect to x using your normal or the general part that we talked about of our parametric equation. Then you use the formula now for the second derivative. And like I said, this formula you are given in your formula sheet. So you just have to interpret with respect to what you are given on that question. All right, so that is how the questions might be given as. If we check here, we've got another question, which is find the equation of a tangent to the curve given by the parametric equations. So sometimes they can do that. They can ask you to determine or to have the equation of a tangent. Because these are parametric equations at the end. So remembering that the equation of a tangent is simply a straight line. Let's consider to say we've got a curve and a line. A tangent simply touches the curve at a certain point. So if we are to determine its equation, meaning to say we are to determine the equation of a straight line, which is given in the form of y is equal to mx plus c, which is the equation of a straight line, where the m from our n3, we said m represents the first derivative with respect to x, because we're dealing with function f of x is equal to, but what is that f of f prime x represent? It represents the derivative of y with respect to x. That's our f prime x, the derivative, the first derivative. So wherever you want to find m, which is the gradient, you have to find dy dx and determine the numerical value at the given point. So you're going to find this at the given point. At the given point, that's you have to substitute the values that you are given at that point or whatever information necessary. Like here we're given where t is equal to what? Where t is equal to 0. So that we have to determine the numerical value. So here we have to determine the numerical value. The numerical value, I'm simply talking about the number, the exact value, right? Whether m is a 2, it's a 3, not in terms of x, not in terms of what? The numerical, that's the number, exact number. All right. So as you can see, that's a direct thing. And as we know that in order for you to have the equation of a straight line, you need the gradient, which is m, and also the point. So the point that you are going to use in this case is the point of tangents. That is the point that you're going to apply, the point of tangents, where the line, which is our tangent, and the curve meet. They meet at a certain point where, at a condition where t is equal to 0, we can have the value of x and also the value of y, because a point, remember, is built up or is made up of x and y. So if we know that a point is made of x and y, you can just substitute. If t is a 0 there, that's e to the exponent of a 0, which is 1. 1 times a third, that will be a third, which is 1/3. If this is equal to 0 here, e to the exponent of a 0, that's 1. 1 times 5, that is going to give us what? A 5. So that's, we have got a point of tangents, which is the point. From this t that we are given, we just have to substitute, right? So that's it, guys. Let us just work on what we need here. Like I said, we need dy dx. And to find dy dx, remember now, that's where you go back to the type of question. What are you working with? Yes, you want the gradient, but what is it that you have? This is a parametric. So how do you determine dy dx under the parametric? So like I said, this is the derivative of y on top to what you are given, y with respect to what? With respect to t, over the one that you are going to have for x is going to be x with respect to t, because we've got x and t there. So that's the idea. So meaning to say, we have simply substitute the derivative of y with respect to t. Remember, y, you just have to drop the exponent on e, 2 times a third, that will be 2/3, e to the exponent of 2t, over, for x, we do the same thing, -2 times 5, that will be -10, e to the exponent of -2t. So if we are to simplify this, we are going to obtain the numerical value of dy dx, which is our gradient. All right. How? we are given that t is equal, where t is equal to 0. So if t is equal to 0, what are we going to have at the end? That's S0 here, which is going to be 1. S0 here, which is going to be 1. So we are left with 2 over 3 divided to negative 10. That is the situation that you'll be having at the end, and this will give you negative 1 over 15. So that's negative 1 over 15. For E, we are dividing the bases that are the same. So like I said, you're going to subtract the exponents, e to the exponent of 2t minus, what are we subtracting? We are subtracting minus 2t. So it's negative, which is going to be a positive. So that's 2 plus 2, which is 4t. So that is how you play around this. So the question is, when we asked about this, no, the question needs us to determine the equation of the tangent. So we said for us to have the equation, we need m, which is the gradient. So we're going to substitute now. Therefore, our m is going to be, if t is equal to, because this condition is not changing, that t is a 0. At any point, even for the gradient, t is equal to 0. So that's e to the exponent of S0, which is 1. Then 1 times this negative 1 over 15, that will be a negative 1 over 15. Negative 1 over 15. That's our m, which is the gradient. So if we take a step back to our N3 and N4, we talked about determining the equation of a tangent or a straight line. Given a gradient and the point, we are going to use the formula y is equal to mx plus c, where m is the gradient of negative 1 over 15 plus c. So substitute the point that you are given, x is a third, y it's a 5. So 5, this is what we got. Sorry guys, I mixed my point here. When this is a 0 here, x is the one that is a 5. So this is just an interchange there. X is the one that is at 5 there. Not to say then the y is the one that is at 0. The y is a third there. The y is the one that is at what? At a third. So that's our x and our y. So meaning to say we are going to substitute y value, which is the y value, a third. So that's a third is equal to minus 1 over 15 times the x value, which is a 5, plus c. So if you cancel this, that will be negative 1 over 3. Take to that side. So you're going to add 1 over 3 plus 1 over 3. And that will give us 2 over 6, since the denominators are the same. So 2 over 6, 2 over 3, I mean, not 2 over 6, but 2 over 3. 2 over 3 is equal to c. So if c is 2 over 3, therefore, the equation in this case of the tangent that we are talking about is going to be given as y is equal to mx, which is minus 1 over 15x, plus c, our c, which is 2 over 3. So that is what you're going to have at the end. So like I said, these typical questions, you just have to be careful with the type of question that you are given. Try by all means to work as much questions as you can, but that is the idea of the question. There's nothing there. That is the whole idea. You can use this to find the equation of a tangent. What is the equation of a tangent? That is your question. Knowing that it's a tangent is a straight line. What are the properties of a straight line? That's what you need. You need m, the gradient. So the gradient, remember derivatives. As long you're dealing with derivatives, we are talking about what? The gradient expression. This is not integration, where integration talk about what? Talk about area. So wherever we talk about dy dx, the first derivative is the gradient. All right? So that's what you might be given. So if x is equal to the sine cubed of theta, then you're asked to find the second derivative, this and that. All right, so remember, this can be written same way as x is equal to sine theta to the exponent of 3. The same thing, y is equal to cos theta to the exponent of 3. So in order for us to have the derivative, the second derivative of y with respect to x, we said this is going to be d theta, the variable that you are given there, of the answer that you calculated, which is dy dx times, we need to eliminate that theta, so it's the theta dx. That's it. So you need your formula and how to use the formula. So as you can see, we need dy dx first. From where? From our formula, we said the derivative of y with respect to x is the derivative of y with respect to what is given in terms of theta. So that's dy d theta over x to what you are given in terms of x, which is dx d theta. All right. So let us see this. The derivative of y with respect to theta, remember, that's a function of a function to the exponent of a 3. So you differentiate the outer bracket. So that's 3. You drop the exponent, cos of theta to the exponent, you subtract 1. So 3 minus 1, that's a 2, times you differentiate inside of the bracket. The derivative of a cos, it's what? It's a negative sign. So this will be a negative sine theta. You combine everything now. Okay? Same thing even here on the derivative of x with respect to theta. Differentiate the outer bracket. Don't consider what you see. Consider the bracket. So you drop this exponent out of the bracket. 3, you subtract 1. That will be sine squared theta. Times, you differentiate what is inside, in, everything inside. The derivative of a sine is what? It's a cos. So that's it. That's it. So that's what you're going to need here. The derivative of y with respect to x is going to be dy d theta. That's dy d theta. We got this answer. So you're going to have negative 3 cos theta squared, which is same as cos squared theta. The sine of theta like this, over the x d theta. The x d theta, we simplified this before, all right? The x d theta, simplify this, we got 3 sine squared. This is sine squared like this, just same as sine squared like that, theta, cos theta. All right, so this is what we have. So if you are to take a closer look, some of the things here are being can be simplified. What is it that we can be able to simplify? Let's check. We have got 3 into negative 3. Sine theta, that's 1. Sine into sine squared, you're going to remain with 1 sine theta here. Here it's 1. Here there are 2, so you're going to remain with cos theta on top. So it's negative cos theta over sine theta. So cos over sine, what we have, that's a cot. All right? So it's going to be negative cot theta. So that's negative cot theta. All right? Sine over cos. So this is what we want. From our second derivative, we said the formula that we have is that we need to find the derivative with respect to theta of dy dx. What we got from dy dx, what we got was what? Negative cot. So this is negative cot theta times d theta dx. What we obtained before, this was dx d theta, this one, dx d theta, this is same like over 1. The moment we are talking about d theta, there's an interchange that happens, so you have to interchange your fraction. So it's going to be 1 over what you had here on x theta, which is 3 sine squared theta cos theta, like that. So what are you going to have at the end? That's the question. So the derivative of a cot, remember I said it gives us a negative cosec. So it will be negative, negative, which will be a positive. So you're going to have cosec squared theta, right? Times 1 over 3. So that will be 1 over 3. 1 over sine, remember, we've got our identities again. 1 over sine, that's a cosec. So we've got cosec squared theta. 1 over a cos. In this case here, there's a cos. So 1 over a cos, we know that this is going to give us what? A sec theta. All right? So meaning to say, we can be able to combine everything at once now. All right. Cosec squared, this will multiply. So it's going to be 3 cosec to the exponent of 4 theta. All right. We have got a cosec here. We also have a cosec here. So it multiplies. So you're going to add the exponent times the sec of what? The sec of theta, the one that we have here. So that's how your questions might be given as. You just have to try by all means to work as much questions as you can, revise as much questions as you can on your parametric equations. What we shall have more questions to come and even from our question papers, so that we see how do they ask these typical questions in the event of you answering any question. You must have the knowledge and idea about the topic that you are working with.